Hi, I'm Craig Johnson with IPEX Electrofusion, and I'd like to introduce you to our LVT tees, our low volume tapping tees. These tees are used exclusively in natural gas distribution. 3-inch mains and larger, you're going to utilize a nylon understrap. 2-inch and 1.25-inch mains, you're going to get a fitting that has this hard shell plastic undersaddle. Let's take a look at our 2-inch and 1.25-inch undersaddle shoe. You'll notice when I slide this out, you've got a taper on your tee right here. There's also a taper in this channel. So this is a directional installation. It only goes together one way. You're going to put your tee on your pipe after it's prepared, slide your undershoe on, and then you're going to send it home with a mallet. Okay, the first thing we're going to do is inspect our pipe. We're looking for gouges, embedded stones, anything that's going to impede our fusion. And we're going to wipe it down with a clean, dry cloth. And while we're doing this, we're actually feeling for any kind of imperfections in the pipe. I'm going to go ahead and demonstrate an installation on an 8-inch main. We've got our tee placed. It's worth noting here, we can put this tee at any clock position we like. It doesn't have to go on top, it can go on the side, go on the bottom, wherever you need to install it, it can go. So right now I'll place it where we're going to put it. And I'm going to mark the footprint of the tee on the side of the pipe. And you'll notice when I do that, I'm going to mark it bigger than the actual footprint. What that does for you is when this is installed and the inspector sees it, the inspector can be sure that you prepared it properly. Now I'm going to go ahead and put our witness lines on here. What those do for you, it gives you an indicator that you have thoroughly removed the oxidized layer in your scraping process. We're going to take a moment to address pipe preparation changes to ASTM F3565. You'll see we've got our area where we're going to have our saddle fusion right here. We've got additional saddle length on either side. This outside line indicates our water wash area. This line indicates our solvent wash area. We're going to thoroughly wash this area from this line to this line with water. Once that water is dried, we're going to address the solvent wash area from this line to this line. We recommend a 96% or better isopropyl alcohol wipe for this application. And we're going to thoroughly clean that with that wipe. Once that is thoroughly dried, you can go ahead, put on your squiggly marks, and get ready to scrape your pipe. To remove that oxidized layer, I'm going to go ahead and utilize our FWZ hand scraper. Once you've completed your scraping, you're going to go ahead and clean this with a lint-free alcohol wipe with 96% or greater isopropyl alcohol. You're also going to clean the bottom of your tee. Now you're going to wait until this is completely dry to assemble it. If you should assemble this and any wetness remains, it's going to flash to steam during fusion and it's going to cause wormholes and a bad fusion. I've placed my tee. I'm going to go ahead and install my nylon understrap. Okay. And then you go ahead and you just tighten up those bolts right down to the stops. And don't tighten one up all the way. Go back and forth so you tighten them up in a cycle so one side doesn't bind down completely. We turned the fitting around because I wanted to give you a better view of the tightening area. You'll see these two bolts at the base. When those come together with those stops, you know you're done tightening this up. Additionally, I want to point out that tapered wedge I referenced earlier. You'll see that's tapered, and this portion of the strap is also tapered, so you know which way this goes on. Up here, you've got your barcode. On this sticker, you've got your fusion code, and directly below it you have a traceability code. It also indicates your fusion time as well as your cooling time. Directly below that you will find a date code stamped in. In this case it's 2619, 26th week of 2019. Let's take a minute and talk about the fusion process. There's 4 factors required to have a successful fusion. The first, virgin material. We attain virgin material when we scrape the oxidized layer off our pipe. The second is heat. We get heat when our processor is hooked up and excites the coil embedded in this fitting and produces heat. Third, we need pressure. You'll see this is marked as cold zone, fusion zone, and cold zone. When this area heats up, it liquefies the polyethylene on the fitting and on the pipe. That material wants to migrate in and out. When that material gets to a cold zone, it actually cools down and dams up. So it produces a dam all the way around the outside and the inside. So as this continues to heat and wants to expand, it can't. And that's how we provide pressure on this type of fitting. The fourth factor, cooling without movement. Before we fuse, we're going to go ahead and check for gaps between the pipe and our fitting. To do that, we take a clean cable tie. We try to insert it in between the fitting and the pipe. Good there. And we're good there. So we know that we have a good interface between the pipe and our fitting, and we're going to get a good fusion. We go ahead, hook up our processor. Doesn't matter, red, white, can go in either one. Going to go ahead, scan our barcode. And if you look over here at the processor, it shows us we've got a fitting, 8-inch IPS. Hit start. Now when this starts fusing, it's only going to fuse for 70 seconds. After that, we've got a 10-minute cool time, and then we can go ahead and test this fitting. We've completed our fusion. We've reached the end of our cooling time. We need to indicate this on the pipe, so it's obvious that this has been fused and it's ready to go. Here I've indicated my initials. You may put your mechanic's number here, your employee number. I've got 1:48, that was the time the fusion was completed. I have 10 minutes of cooling time, meaning we can go ahead and pressure test this at 1:58. To pressure test this, once you have this outlet attached to something and you can close it off, you're going to go ahead and remove your cap. And install your test cap. You'll notice there's an O-ring on the inside of this cap. You have to keep this clean. If you don't keep this clean, this won't seat correctly, and you're not going to be able to get a test. So you go ahead, you tighten that right down. You would add your testing apparatus to the top. And then before you tap this, you get this pressure test cleared. Let's say something happened and you didn't pass this pressure test. You haven't tapped this pipe yet. You can go ahead and cut that off and put another one right next to it. We've passed our pressure test and it's time to tap. Take our tapping tool. It's going to go right into the well inside. We're going to go ahead and run that cutter all the way down through the wall of the pipe. When we bring it back out, it's going to open up the supply and that'll be live. We ran our cutter all the way down. It pierced the wall of the pipe. That little coupon of the pipe is now captive inside that cutter. We brought our cutter back to the top of the chimney. Now we need to give it an additional quarter turn after we hit the stop, and that's going to seal the threads near the top. All that's left to do is replace our plug cap so it engages with this O-ring and seals the top.